So let's look at today's examples for sapply and lapply. So the basic words, the lapply, where L stands for list. So as we saw a table last time where apply, lapply, and sapply return different data types, as the name rightly suggests, lapply returns a list of vectors or objects, and sapply, the word the letter S here stands for the word simple. So what happens is lapply, it always returns a list, and if you desire to have a list as your output, then you use lapply. And if you just want a simple vector of objects that should be returned, then you will use sapply. So both essentially work the same, but it only differs at what you want to see as the end result. It's different data structure. It's the way it returns. So other than that, everything else works the same for both these functions, lapply and sapply. So the other thing is if you could recollect the last classes, most of these functions in R, they work on vectors. And many of these functions, they used vectorized operations. But we saw one example like the switch command, which takes only a value and not a vector. And therefore, in our previous example, we did use switch as in a for loop. And if you recollect the last class, we did look at all the constructs, the looping constructs in R. It's for loop, if else, and switch, and other such looping constructs, and we saw some examples too. So in those examples, we did use switch. And I'll just in some time right after the next slide, I'm going to show you how the switch function in a loop can be easily replaced by using sapply function. But sapply is efficient as to use as a programmer. It's less clutter of code, and in just a minute I will show you how to transform the previous function price calculator by using sapply and switch. So just using for our very first example to use sapply, we'll try this very simple piece of code where you are in sapply, you are passing it a vector, and this vector is a series of characters. And in this, I just have two characters in this vector, it's A and B. And then the second argument is what function you want to run on the vector that you gave in the first argument. So we want to run switch function. So if you remember, the syntax of switch is going to be switch, and the first argument will be the vector, and then our arguments will be these results of based on whatever the vector value is, you switch and choose particular values depending on what your vector has. But in sapply, we just give it the bare function name. Remember, we are not giving the full syntax of switch. We are just giving the bare word of this function, which means in sapply, we are asking sapply to run this function on this vector. Run this function on this vector. So, and depending on what the values are, you pick, if it's A, you pick hello, and if it's B, you pick goodbye. And depending on what your vector is, if you give it a default value, if it's not A or B, then it picks that default value. So let's just try this one example. I hope everybody has your RStudios open. We are going to try just this one example. I want you to try this because sapply and just apply are a pretty easy way to use functions on vectors, and it saves you a lot of time and clutter of code to not use the loops, but just do these operations in one single line of code. So just open your RStudios. I have this example from our previous class, but I'm going to maybe pick the values vector. So I'm going to write my sapply over here. So you have to use the keyword sapply. The very first argument is the vector you want to run the function on. The second argument is the vector we want to run the switch function. The second argument is the function you want to run the switch function on this values vector, and then we are going to give the switch parameters of based on what the value should be depending on what value the vector has. So we are going to say hello, and I'm going to give some values depending on which value it is. So I'm just going to include a default value here, and goodbye is going to be my default value, and I'm going to run this and this. So my vector has A, B, and C. If you look at the values vector, I have the values A, B, and C inside my vector. So depending on those three values, it's going to pick the switch function is going to run on the values vector, and it's going to pick the appropriate choice depending on what value that vector has. So since we have the first value of A, it's going to print hello, and for the B it's going to print XYZ, and C is going to print goodbye because we have a default value. And if I don't have B, if I just have two values, then it's going to print two goodbyes because both come under default values. So I just take a minute to write this one line of code, this sapply code. Just give it anything. You could give it values. You could make a values vector before running the sapply command, or you could give it directly inside the sapply command. You could give it a few characters, and you give it the switch function. You give it the choices for this switch function, and run it in your RStudio. So just take a minute to write that, and once you have done, just put done in your chat box. So this family of functions sapply, lapply, and apply are very useful to run functions on bigger data structures, like a matrix or a data frame or any such vectors. For a single value, you don't need sapply and lapply functions, but for a series of values, a series of a vector or a matrix and such, you want to use these. All right, so everybody has done this. Good. So let's move on to our next example. So this example, since you have already seen this basic example, we will now move on to the next example, which is this one. So if you remember from our last class, we had this example, price calculator example, where you give it hours, price per hour, and the client, and based on these three arguments, it's going to perform some operations. You're going to calculate the next net price, which is the product of hours, PPH, and you are giving the client a discount if you have worked for more than 100 hours, then you're giving a 10% discount. And then you calculate the VAT, and within this for the VAT calculation, you're considering the client values, and the client based on whether it's a public company or a private company. You use the switch to pick those values. So right now in our example, we are going to say, once again, I'm going back to my RStudio. I have this I have this function from our previous example. So, so right now I am doing a VAT assignment to zero, a numeric 0, and then using the switch command. So instead of this, right now I can use the sapply function the same way that we just ran, the sapply function over here, and I can use it on calculating the VAT. So what I can do is I can do sapply, and I can give it based on, the first one is going to be based on the client. I use this function switch, and then within then I have to give it the results and which values to pick. So depending on, I don't know the exact numbers, so I'm just going to use some random numbers. Private equals, and then public equals. Okay, and I'm going to give one default, which is if it's not a public private or public or a private, the value of client, if it's not a public or a private, then it's going to pick the default value. So this is one way where, and this you could assign it to VAT. So so here you see what we did, right? We replaced the whole for loop with this single line of code sapply. So likewise, you could, I have the same example over here. We are replacing these 4 lines of code with this 1 line of sapply over here. So this way you could have a very concise code, and it's easier to write. And this is also, it does the work for you. You don't have to think loops or getting to every single value in a vector. It's going to, the supply family is going to automatically run it for you. So we in the real world do use apply and mostly sapply, and sometimes lapply depending on what we want. If we want a list to be returned, then we use lapply, and this is used a lot. Like you cannot write a useful program without these, because that's how in real world you will have to deal with more complicated data structures, and this is what you need. All right, so we'll go on to the next part of today's session, which is handling data in R. So till now we have looked at most of the data structures. We have looked at vectors, arrays, matrices, data frames, and we have looked at several looping constructs. We have looked at how to organize your code into functions. We have looked at all the looping constructs, if else, conditional coding and conditional testing. And we also looked at how to use the apply family of functions. But today we are going to, we are kind of working backwards, because I didn't want to get to the part where you load the data without having the knowledge of some of the basic data structures and how you can put data into R. So today we'll look at how to load data into R. So there are multiple ways you could have data in R. You could just do it through clipboard, meaning if you have a text file or an Excel file, you could choose the particular cells you want to copy and use the Control-C, Command-C, depending on whether you have a Mac or a PC, and you could just copy that, and then it's stored in this invisible clipboard, right? So you could just import, and I'll show you by the end of this session of how to import what's in the clipboard into R. And then most of the time in the real world data, if it is like streaming data, or most of the data science files are in this format, comma separated values, meaning every row is separated and every column is separated by a comma. So those are the CSVs, as we call it, comma separated values. The CSV formats are some of the very commonly used widespread format. And of course, we use spreadsheets a lot, like everyday use. So there are packages in R that could read an Excel sheet, read one particular sheet within the spread workbook, um, and particularly pick. It can run operations on Excel. We can also write to Excels. So generating Excel sheets is going to be like, if you are dealing with people who don't know code, then the way you have to share your data or share your results is going to be to write it to, within R, you write it to a spreadsheet. And there are other statistical packages. SPSS is one such statistical package, and R, some of the packages in R also have the ability to read it from SPSS or even a SAS data set. Like so you have a different format within SAS, and some packages in R can also read from multiple formats. Like if it is an SPSS file or a SAS data file, it can still read it using those packages. So I have some information towards the end of this session where you could like dive deeper into each of these formats, and depending on what format files you have, you could install that particular package. And installing packages in R is not very difficult. It's just a single line of code, and RStudio and R is going to install all the dependencies, meaning whatever the package depends on. So most of these packages are written in a form where programmers use some previous packages already built in R or some third-party packages. So with install, I think this one I showed you in the very first class, that if you use install dot packages and you give it one particular package, and you give it one particular package within this, it's going to install all the dependencies. And all the packages will be over here in your right hand side, and you can see all the packages being listed over here that you have already installed. So if you do this, R is going to install dependencies and that package too for a particular package to be installed. So let's go back to our example. So R can import files from other softwares, and you could easily use the data import tool within RStudio, and you could import data from a website or even text files depending on what you have. So mostly importing data from websites is used for web scraping, or the people who are trying to for reviews or web trends and things like that. This is more of a data scientist job, and this is something which we get most requests for also, like traditional relational databases. Some people, some companies still use them, and we have Oracle, MySQL, Postgre, SQL, and DBI package for Oracle and other databases. So you can import data from any of these databases. You have different packages in R to be dealing with each one of these databases. And towards the end of the session, I have some links where you can go and explore more if you have a particular data type that you want to import into R. But most commonly used is the comma separated values, CSV files, spreadsheets, and clipboard also sometimes. But I don't use the clipboard a lot because depending on the size of the file, you either have to have it in a comma separated value format or spreadsheets or even text files. So any questions so far? Okay, so let's move on to this example. I have not written the whole file. Somehow I'm missing this file, but I'm going to use this example file, part of that the spreadsheet that I've shown you. So this file is basically a periodic table, um, some data from the periodic table where you have different elements and you have their symbols, you have the group, and you have which period it belongs to, block, what's the state of this element, and just the occurrence. So we are going to use this spreadsheet and we are going to see how to import it, or how you could use the inbuilt text editor in RStudio. So let's look at our first text editor. And if you're using Mac, this is something that you will the errors that you will get for using the editor, that inbuilt text editor in RStudio. So let's do this one. Let me just go into my RStudio, and each one of you can try this. It's very simple. So let's have anything. So I'm calling it elements as my variable, and just saying that the elements variable is going to be a data frame by using this data.frame. And now what I'm going to do is I'm going to use the edit function to pull up my editor. I'm going to use the edit function, and I'm going to pass it the empty data frame that I just created. So when you do this, you have this window popping up. It's a data editor, and you could directly go in here to enter data. You could tap on the column names to change the columns. And when you tap on the column name, you have two options, whether to choose that the values in the column could be a numeric values, or they could be character values. For now, since I need the atomic number to be a numeric value, I'm going to choose a numeric. And you could change the second one to be element name, and it's going to be a character. I'm just going to enter 3 values. What is 3? Lithium. All right, so I entered 3 values here, and there is no, if you see, there is no save button or anything here. There is a copy paste button where you could copy and paste from elsewhere, and there is a help button. But once you close this window, it's automatically saved. It's automatically saved. To know if it's saved or not, you could either look at your environment. It says 3 observations, 2 variables. You could tap on this, and the data comes up over here in another tab, or you could just print the elements in your console. So I'd like you to just take a minute, try these 2 lines of code. Just assign an empty data frame by typing in data.frame and assigning it to this elements variable, and then to the same elements variable, you are going to use the edit function, edit, and then give it elements, which is going to be the empty vector. Then the window for editing pops up. So I want you to just try this one, just to get a feel of how you could enter data. You could meticulously type in data, but this is for smaller data structures, and if you have like smaller number of rows and columns. But for real life, we almost always never use it unless it's a very small data. And if we are so the one use of this is, suppose if we have scanned documents, handwritten or scanned documents. So that's one way we could use the edit. Okay, I have one question here. When I type view elements, it says it could not find function view. It's not view, it's edit. EDIT. There is no view function. So this line is what I asked you to try. It's the edit function that you need to use. So I hope you got a chance to try this. Just type done in the chat window once you have done this. Yeah, okay, good, wonderful. Okay, so as I just told you, this type of editing elements is useful if you have like scanned piece of paperwork where you have to type in the data anyway into like an Excel sheet, or you have to like literally do data entry work. So for some of our lab colleagues, they do use lab notebooks, so they do the handwritten documents and write their measurements in notebooks. So for this type of data, we do use this editor in order to get them into R. So let's move on to our next way of entering data. So this is what we saw previously. So you could just print them, or you could just use elements in order to see what that has. And you don't have to save this separately. Once you close the editor that has popped up, you will have your work saved in that variable. But please remember, you'll have to assign it to elements. If you just did edit elements, then it's going to pop up, but it doesn't save anywhere. You'll have to assign it to another variable, or you could assign it to the same variable. Okay, so let's look at how to do the copy and how to read from the clipboard. So in order to read from a clipboard, what you do is, I have this elements spreadsheet over here. What I do is I select the part that I want to copy and do a Control-C, or you could do the copy from here. Just copy, select and copy the data that you want to put into R. And then inside R, you could do a read.table function. So this read.table, it takes it's a generic function. So you could use a read.table, and you could use the file equals, if you write clipboard over here, and you could give a separator, since Excel sheet is actually separated by tabs. You will do a tabs, and if you have a header for this, header is the column names. If you have a header for this, type header equals true, and then it will assign the top rows to the column names. So this is the way. So if you look at this, it did read from my clipboard. I just copied it, and it's going to read.table is going to read it from the clipboard. And you could assign read.table to any variable and just hold it and reuse that variable for future operations. So similarly, read.table works for text files. So if you had a text file, you could give it the name over here. And again, be careful that you'll have to set the working directory to wherever this file is. If that is not the case, you will have to give the full path, C colon, wherever it is. It's in the desktop, give it desktop, and give 2 backslashes. So give it the complete path, as I told you in last class. You'll have to give it the complete path for R to find that file. So this way you could read a text file. Of course, I don't have the text file, so it's giving me an error. And so if you want to read an Excel sheet, it's going to be XLS, but read.table cannot really read an Excel sheet. So it's going to be, you'll have to use another package, which is, I think it's XLSX, like I have over here. So I just loaded that package, and you could use if you see here, I have 2 functions here, read.xlx and read.xlx2. So you could use any of these functions to be able to read from an Excel sheet. So clipboard, we have covered Excel sheets. So let's go into CSV files. So CSV is one of the most commonly used formats in any data, in say for data science or wherever you need to load data. So CSV has a separate function for it, like the read.table. So you could use read.table for having data from the clipboard from a text file, and you could use read.xls from the XLS this package, XLSX package. You could use read.xls for reading spreadsheets, and you could use read.csv to read from a CSV file. So I hope anybody, so most people might already know this, but you could easily convert any spreadsheet into a CSV file. Suppose if you have 1,000,000 rows, Excel will start complaining, or it will not load depending on what size memory you have. So you could easily convert this and save this into a CSV. So if you look at all the formats available in your document save type, you will find, a text, a tab delimited, and you could save it as a text file, use the read.table to read it into R, or you could use the CSV format here, CSV comma delimited, and resave that. All right. So where were we? All right. So you could save any of these Excel files into a CSV format and be able to read that CSV file using the read.csv format. Okay, so that's something you could try. Save, take an Excel sheet, save it as a CSV. Make sure you set your working directory to wherever this file is, and then use the read.csv to be able to give it that CSV file. You could either use this, or you could do a read.table. You could do a read.table and you could give the separator as a comma. So there are multiple ways of reading the files depending on what you could remember at that time. If you think your priority is writing smaller piece of code, then using the read.csv function works much better, because you give it one single argument, just the name of the file, and it's going to read into whatever variable you have. So everything clear until now? Anybody has questions? Anybody has questions? Yes. So what question you have, Mahesh? I think I lost somebody. Oh, you missed a few slides? Okay. Okay. So I think I apologize for my connection. I think it's my connection today. It's kind of giving me trouble. So let me just recap what we have just looked at. So you didn't miss much, Mahesh. So one thing is that you already tried the R text editor, right? You already tried this. So the other thing that we talked about is reading from a clipboard. You could open the Excel sheet. You could just select the area that you want to read into R, and type and just use the copy button from the file menu, or you could use just Control-C, copy it, which means the data is holding within the clipboard, and use read.table and give it specify the file as clipboard. So make sure you don't have any typos here, otherwise it's going to look for that particular file. So make sure you don't have typos in the clipboard. If you just give it clipboard, it's going to read in the part where you copied from Excel sheet or text file into the clipboard. Give it the separator, give it the header, so everything is going to be read into from the clipboard into R. And this is the other thing that we were looking at, which is a CSV file, comma separated values, where the comma separated values file, CSV file, can be generated from an Excel sheet. If you just go to the Excel sheet, use the save as, and you have multiple choices and formats over here. So you could pick the CSV Macintosh, depending on whether you have a Mac, or CSV comma delimited, just to and convert it into a CSV. Okay, I already have it, so I don't have to convert. So once you have that, you could use this function called read.csv and type in the file name. So again, before this, make sure that you have the right working directory set. In order to check your working directory, you could use the getwd function and see where your working directory is. Mine is not in the right directory. If it's not in the right directory, you can use the setwd function and give it the full path where you can find that file. Give it the full path, C, whatever, depending on whatever your path is. So I am not going to run this because it's going to go back to my C drive. So use the setwd, set the working directory to wherever your wherever your file is. Then you could use the read.csv to read in the file. Okay, so everything clear until now, Mahesh? Okay, all right, so let's move on to our next slide. So what happens in the CSV? I have this vec.length function written over here. What is it? It's going to set the number of variables that you need to display when you use the structure function. So you remember from our from our first few sessions that the str function stands for the structure, getting the structure of that data structure of that variable. So give it the variable and this parameter within structure vec.length equals 2. This is nothing but it's going to, depending on what data type it is, for an integer, factor, we have integers and factors. Depending on what data type is, it's going to display certain elements from those. Like if it has levels, it has 10 levels, right? So it's going to display 2 levels from this. And I don't know the exact number and the exact conversion between that, but if you guys find out about like why it is 2 and why it's displaying like 4 for these, yeah, just let me know in the next class. It's not that important really, but I just have it here just for you to be able to see that you could use that in case you want to look at more levels. You could increase this number and it's going to display more levels depending on what you have, what number you have here. So the thing that I wanted to say here was whenever you read a CSV file or a clipboard or from a clipboard or from a text file, anything, if it has a character, if the column has characters like this, so in this, the first one is a numeric, but the second two are characters, right? So if you have characters within your data, R is going to automatically convert it into factors. I hope you still remember what factors are. So factors are a way of displaying categorical data in R. And you have different functions for factors. You can identify values depending on the category. If it is a factor, it's a different data type. But it's going to automatically, while reading, any character is going to automatically be converted into a factor within R. So this is one of like the very first things that we do whenever we read in a file. If we don't want R to convert it by default into a factor, we use this parameter, which is called strings, as factors. Strings, please note this capitalization. In RStudio, you really don't have to worry about typing this, because whenever you start typing it into, say, read, if I have read table, so let me go to my previous example over here. If I want to read this table, okay, let's read from the clipboard. If I want to do this, if I start typing string, it's automatically going to give me whatever that argument, that parameter is. So you could just type on that and it's going to write that for you. So you don't have to remember where the capitalizations are, but if you're typing in everything, then you could use this, or RStudio is going to suggest for you, so you could just pick that and you give this true. So if you want, so within this, so by default it is true, and that's why every character that is read into R is converted to a factor. So if you don't want the automatic factorization of your character columns, you have to set it to false. So when I set it to false, sorry, I think I don't have anything in my clipboard, and that's why it's complaining. Let me just pick this. Okay, so now if I give it elements, it's going to not consider. Let me use the str, only then I'm going to know like what class or what data type that belongs to. So now you see that this name and symbol and the block are characters and not factors. So if I had it the previous way and had not specified this one, it's going to, if I do the string of elements, it's going to convert it into a factor. So you see the factors over here for all the character variables. So what is, you may ask, like, what is the difference between the two? I would suggest you to go back to our session, I think it's 3, and read about factors. You could do a lot more with factors. If you want it to be a factor, you could do a lot more with factors. But instead, sometimes if you have different, like the name of the atomic gas, right? So the name of the atomic gas will be like all the elements in the periodic table, and each one is going to be different. It's not really categorical information. It's going to be different elements, so it doesn't make sense to categorize them. So that's why I want it as a character. But block, you want maybe the block as a factor, because that is categorical. You have the SPDF blocks, right? So you could have just the block as a factor. Then if you want just one of it to be turned into a factor, you could do it separately, like elements. So let me just have everything as strings. Now everything is character, and now I want to convert just this one, the $block, into a factor. So I could say factor. Remember the way we could create factors? So I could say a factor of elements and block. I could just say that, and it's going to give me 2 levels. It's going to be P and S. So those are the 2 levels that I'm looking at. So you could do factor. You could use the factor function to convert any of these columns into factors. So let's go back to our way of reading CSV files. So read.table is more, so this one I already showed you, right? So read.table is a more generalized form of reading. So if you want to read, if you want to use the read.table for reading a CSV, then you have to change this tab to a comma, and then it's going to read the CSV. And since we gave it a tab, it's looking for tab as a separator. So so what it did is it put all the data in one column. So that's what is going to have if you don't specify the correct separator. So within RStudio, you have this import tool. So you could use that tool. Let's look at our RStudio, and you have this tools over here. So let me look at that tools, and let me see, where is my import tool? Okay, so in RStudio, I think that was an older version when I made the slide, but look at this. So you have within the file, you have import dataset, import function. So within this import dataset, you have all these options. Get it from a CSV, get it from an Excel, get it from SPSS and SAS, which is a SAS dataset. Stata is another software for statistical programming. You could use any of these and use this function and import. So whenever you type this, you will have the dialog box pop up. It's going to, oh, I don't have that package, so I'll have to install that package right now. So I'll let you try it on your own. So you'll have to use that and import. Let's just try the Excel sheet. No, it still needs that package. So there are different packages for it if you want to use that, but it's going to be one convenient way of importing data. And this is in Mac. I don't know if anybody is using Mac. You might see this under tools. So RStudio on Windows is slightly different from the options you have on Mac. So it may look different on Mac. Okay, so for other data types, you have other ways you can do it, and this library foreign is one of this very old package that you could use for reading in data from this SPSS. Like you could use this read.SPSS, like the same way you have read.table, read.csv to be able to read this SPSS type of file. But this package is a little old, and I'll have to look into like some of the latest packages that there are to read such type of files. So this is the actual slide that I was talking to you about. It has information about different ways of import and export. So the same way, all this while we were trying to import the data, right? So same way you could use certain commands to be able to write the data to into files. So you have, for further reading, you have I have listed all this here. So you could use the chapter 4 from the R manual, and that's the website is given over here, just to look at the import-export mechanisms in R. And for relational databases connectivity, if you want to be able to connect from your R code, if you want to connect to a database, you will have to have some packages installed, and you establish an ODBC, Open Database Connectivity, and then from within the R code, you could give it, open connection, and you could give it the user ID and your password to be able to connect to that database, then pull the data from there. So this is for Oracle or any other database. And for MySQL, you have a specific package called RMySQL. That was a more lighter form of connecting to the MySQL database. And you have SQLite, you have PostgreSQL, and a database interface package also to attempt to connect to different databases. So just go through the slide. I have everything listed over here. So if you are interested in more data types, importing data from other databases, or if you have different data files that you want to do. So most of the common things that we covered in the class are pretty much enough for most common data types. But if you have to connect to databases, I would highly encourage you to take a look at one of these and be able to figure out what you need for to establish a database connection. So similarly, as you import data, as I was just telling you, you could export data too. So you could do you have these functions like write.csv and write.table, similar to read.table and read.csv. So in the same way, what you could do is you could do the write.table, and you could write, you could give it the vector or whatever variable you use to store your data within R, and you give it a file name to write to. And you could use different delimiters. You could do a CSV, or you could do any delimiter that you want. You could just give a space or a tab to be able to write it to an Excel. And you have other parameters. You could take a look at this. And just to write the read.table, write.table are more generic form of files. So you could use those to be able to write tables and write tables into a text file, or usually we name it as a text file. But if you do a CSV, then you will have to have a separator specified within write.table, and separator specified as a comma. And instead of this, you could just use the write.csv. It's going to automatically separate your data with a comma in your file. And also, I think so one other thing is, if you want to be able to write whatever is on the clipboard to a file, you could use this write clipboard function. Although this wasn't there for reading clipboard, I hope there is a read clipboard. I haven't looked into it. I think the way we always did was to use read.table and file as clipboard, but there is this function called write.clipboard where you could give it whatever is in the clipboard to pass it into a file. So that's all I have for today, and I'm going to and we are right on time. And any questions so far? Any questions, anyone? So let me stop my recording.